hire only FP experienced programmers. So to get you a brief summary, we'll talk a bit about our context. Then I'll try to walk you through the path we use to onboard new people, and then we'll talk a bit about the rationale behind the last story. So first, I'm Antoine. Hello. Welcome at Swan. Thank you for being here. I joined Swan last year, and I'm in the payment team, so I'm developing core banking functionalities and features. So at Swan we have three distinct tech stacks. We have the first one, which is the Java-based stack with Scala and the whole type of libraries. We have the not packet-based one, which is using TypeScript and then FPGS, which is a functional library for TypeScript. And then on the front end, we have React Native TypeScript and Box, which is a library our front-end team developed and published on open source. So you can see we do a lot of FP at every stage of our Okay, so as you may know, hiring people that are already knowledgeable about functional programming is a bit of a challenge. We are still in some kind of niche. So instead, we try to find people that are enthusiastic in learning functional programming, so curious people that want to learn. And so we have to have a dedicated onboarding strategy to get them to a level where they can be productive here. So let's talk a bit about the goals we have when we try to onboard someone. So first, as you already may know too, joining a company is hard because you have to learn a lot of things on the company process, on how the code base is structured, how you do contributions, and also the whole business domain. And as Edward said, we have quite a dense one because we are doing banking things. It's a hard domain. So we try to let the newcomers focus as much as possible on learning those things, more than learning and trying to decipher functional programming. We want them also to be autonomous as much as possible and as soon as possible on navigating libraries documentation, and so they can learn by themselves on a specific task. And the third one, on a more personal level, we want them to be able to start their functional journey as soon as possible and try to learn new things by themselves without fear of the unknown. Okay, a little disclaimer. So we try to focus on concepts that should be useful right from the start, or concepts that give some sort of, that get rid of some sort of fear. And we try to give them intuitions that may not be correct or may not be mathematically correct or theoretically correct, because we believe having a good intuition for the first 6 months is better than trying to learn everything from the start. Okay, so let's try to walk a bit through the results. I hope a few people will learn something here. So what is functional programming? So it's a paradigm based on writing pure functions, on applying them and composing them. So a pure function is a pretty easy concept. It's a function that has no side effect. So it's a function that has nothing that happens on the side of computing and redoing a value. Here we have two examples. The first one is quite an easy one because we rely on mutating the variable state to have behavior. On the second one, we have just a function that takes 2 ints and gives back a result by adding. So purity is an important concept in functional programming, and it's also really linked to referential transparency, but I might say RT because it's hard to say. So Again, an easy concept in a vacuum. So an expression is said to be referentially transparent, or RT, when it can be replaced by its value without altering the program behavior. So again, two examples, you can see that we use the function I just showed you. So first one, we have x that is equal to I2, and we try to create a tuple with x, and then a tuple with just the function by replacing x by its value, so equal to. Here we can see that so by modifying by replacing x by equal to, we also alter the behavior of the program, because on the left side we have a tuple with 2 and 2, and on the right side we have a tuple with 2 and 4. So x is not transparent referentially. On the second example, we can see that we have a simple sum, so pure add 2. And when we try to replace x by pure add to 2, we have the same thing as if we didn't replace. So a tuple of 4 and 4 on both sides. So x in this example is transparent referentially. So we talk about this concept to our newcomers because it comes with cool implications for them when they dig the code base. First one, when a function is RT, it do not lie, so it does not lie, so you can trust the signature, and if you see a function that takes something and give you a hint or give you an option, you know that it only does this, it only gives you something. And then we also teach them that they can use substitutions when they see a piece of code they can't really understand, so they can reason on the more easy property. Last of the basics, so function composition. A pretty basic concept again. So it's a way to create function from other functions. So say we have a function that takes an int and not incremented, but add 1 to it and then returns. We want to create a new function that takes an int and then add 2 and then returns it. So we could just write that, that's easy. But we also can compose add 1 2 times to get a new function from the simpler function. So it's again an example, so it's hard to see the value here, but it's okay. So let's talk about type class. So a type class is an abstract type that represents behavior. It's also a way we have to describe unconcrete types, whether they are our types that we created or they are closed type from other libraries. It's a way we can add to those types behaviors without subtyping. So on the closed type, you can do behaviors. Let's have a little example to show type class convention. So I'll show you show, which is, I think, the most basic type class we can have. So show gives the ability or the behavior to transform a value to a string representation. So here is the type class show. So it's an abstract type, it's a trait in Scala. It's parametric on A. And we can see there is a function show that takes a value of type A and returns a string. So let's get to using it. We have a type person, a name, an age, and we want to use the show type class on this type. So we create what we call an instance of the type class. So here we have an instance of show for person, which is a basic implementation. It's the same one as the toString method on base classes. But now that we have this instance, we can do more things. So here, let's say we have a send message to Kafka that is parametric on A, on the type of the message we want to send. That takes a key, because it's Kafka, and a value of type A. And we want to try to write a little functional layer to it. And we decided at some point that the key of the message would be the value of the show instance for this. So we write beta send message to Kafka, which is parametric A, and has this little thing that says to us that we want every A to be passed to the function to have an instance of show somewhere accessible by the function. So then we can just use value.show. So people that know how typeless instances work know that it needs more magic than that to do this. Let's say OK. And then we can use the show instance to send a message to Kafka using the solution. So it comes with two things. First, by reading the type signature, we have clear and readable information about the function needs to needed behavior from the types it takes to execute. And also, it comes with a few compiler errors if we try to pass to this function a type that doesn't have a show instance. Okay, so I'll try to get you through a little example. So we'll start with function. I think a lot of you know about function, I hope. So it's a data type that represents the possibility of a missing value. Usually, on, for example, Java, it would replace a null, for example. So it's defined like this. You have the constant object none, which represents when there is no value, and the case class sum with the value of type A in it, which represents the case where there is a value. And so, again, a bit of code, two enumerations. I'll let you read a bit. Pretty simple enumeration. And then two functions. So we have a first function that takes a string and gets us an option of country. So why an option here? Because not every string is a valid country in our system. So we decided to model this using option. And then we have a simple transformation function that takes the country and gets us back to currency. And then here we chose to have a default case because we chose in our business domain that USD would be the default currency for the country we live in, or for a country we would have another currency for. Okay. So, if you remember about the function definition I talked about a bit earlier, you might want to, you might understand that we might want to compose those functions. So if we try the method we had on the first slide, so the end then, it doesn't really work because the types don't match. Find currency by country doesn't take an option of country. It takes a country. And so to get rid of this type not matching error, we just need to introduce the map operator. So here we have to map things to compose those functions. So map is a behavior that comes with the type class funter. That's a type class that represents the behavior of transforming a value without leaving the context of the value. So if we get back a bit, here we have the first contextual value here on the parse country because, as I said, not every string maps to a valid country, so we have an option. And we don't want to leave this optional context because it's interesting for us to know that what we try to do isn't existing. So we can talk a bit about the signature of map, but I think you may know it. It's a simple one. Usually what I tell to newcomers that before explaining higher contact types is that the F in this case is the option because it's easier for site to sense. Okay, so now let's try to do the same path to go to another type class, which is monad. So we have the first stem function, and then another function that takes a country and gives us a BIC. So a BIC is a bank and identifier code. which we use to identify financial institutions with a unique code. So in our system, we want to have a unique peak by country, but we don't want to have a default peak. So we don't want to give for example, the French peak if we get Japan. So here we chose to make the function return an option. And in the case of it's not France or the United States of America, we just say no. Okay. Again, we want to compose those functions. So the first solution doesn't work. So the mapping one is working, but not in the way we want, because we get quite cumbersome type, which is not an option of pick. And it's a bit hard to work with the steps, honestly. So again, we have to introduce a new operator, which is flat map. And then like this. And this type, and this is what we want. Flat map comes from a monad type class, and the monad type class is a way to represent the sequencing of computation. So again, if we take a look about on the example, you can see that we have a first computation here, past country, and we want to sequence it to the second computation, which is okay. Now I have a country in the okay. A fun thing about funter monad that is quite hard to know for beginners and that we want to press on is that you can't do context modification with funter. So once you have a context, so for example, in the first example we have a something, you can change it. So you only can change the value in the context, not the context. But with monad, we can change the context modification. We can change the context without changing the context type. If you start with optional context, you stay on the optional context. And you can see here, instead of sum of none, we get a none. That's the split. Okay, last thing I'd like to talk about for newcomers is IO. So IO is a data type that usually describes side effect as pure values. It helps us lifting impure things into our pure domain, and we can manipulate IO as a monad. So it's quite interesting to have as. So that's quite a short presentation for IO. We could do, I think, 30 minutes on it, but the fact is, it's just a way to demystify things. By talking from the start about how to do meaningful things. Okay, so why? Here is the concepts I show you now, and I usually show to newcomers when we write Swan. I divided them in 3 subsets. So the first one is fundamentals. It's, I think, things that everyone should know about functional programming, because it's like the first, it's FP 101 basically, and also usually people arriving at Swan usually know this because it's pretty common knowledge on functional programming, or they just typed functional programming in Google, to be honest. And it's interesting because they know, with this knowledge, they know what they can expect in the code base, and so they have the tools to first try to dig for the first few weeks, for example, and they also know what they will be expected in the future contribution to our code. Sorry. So the second subset is funter and monad. So as you may know, map and flat map are in every language now, not only functional programming ones. So usually they arrive with the knowledge of map, but they know that they use map as a way to iterate on collection. And we want to read a bit of that intuition because it works, it's okay, but we want to give them another angle of looking at map and flat map so they can start thinking about this and trying to understand, get a deeper understanding of their purpose. And then IO, so IO is about a personal story, to be honest. So I did a Haskell class in school a few years ago, and we wrote a lot of map, of fonts, and of zips, but we didn't do anything but execute it outside of the Haskell repo. And for a long time, until I took on functional programming by myself, I wondered a lot about how do we do write programs that can, make an HTTP call, make a request. And so, by talking as soon as they arrive about I/O, I hope that it's demystifying this thing and letting them know that we can write everything in FP. It's just an override. So, once we have this done, usually it takes a lot of time to digest all this information. It's a new thing for most of the newcomers that arrive. And I think it would be delusional to believe that in 1 week or 2 weeks they can have a good understanding of these concepts. It's too new for them. So it's more about planting seeds and getting them to meditate on these concepts and making them try to understand more deeply by themselves, more than it is to teach them the concepts and believing they are ready to understand everything. So then, we do a lot of pair programming because it's a good way to repeat things on functional programming. It's a good way to explain more things, and it's also a good way to show them how our code base is structured and how our business domain works. So it's a good tool. Evidently, code reviews. It's also a good place to learn things on code reviews, seeing their mistakes and trying to get them to, by themselves, to a better understanding of the mistake we see. And obviously, we all were beginners at once, so we have to be empathetic. We have to not give up on them, keep explaining things, keep getting them to try to understand this. So it's hard, it takes time, but we have to understand that and keep going with new explanations, with a new way of showing. Okay, little self-reflection of the process. So obviously, it's not like a silver bullet of explaining functional programming, not at all. It's a good trade-off for us because it allows newcomers to contribute soon when they arrive. So in the first few weeks, they are able to do meaningful contributions and get something in production. So it's a good way to make them satisfied about themselves, making them feel useful, and keeping them motivated to learn more and more on functional programming. Also, it's something that works because we have a pretty big team on the Scala side, but we don't really have like a big spread of model. It's pretty homogeneous, so everyone can just assist a newcomer and help them get into the next steps. Thank you.
So, usually, do you think that it's very good presentation? So, do you often find people to understand more from which way, from examples, from going, for instance, when you present type class, you go more into, okay, so you need to see that function, type signature, oh, by the way, this is called this, or do you more go from all the theoretical side and bring them, and then this translates concretely to these type of things?
I think there is no there is no like one answer because it depends on the person.
So both work differently.
I think so. I think you have to have examples because it's a good way to show these concepts in action. But I believe if people are okay with theory, more theory-based learning, it's okay. I mean, I don't think there is much of a difference. It's mostly on the people preference, let's say. And so we have to adapt. So we have to sometimes use more example or less because we have to adapt to the people. And also, it's also, I think, it depends also on how much of knowledge they have of functional programming first when they arrive. Also, because a complete newcomer, a complete beginner won't have the same needs as a false beginner of the same language. Okay?
Yeah, I'm just surprised that you didn't mention the mutability. Is that mentioned?
So,
Can you repeat the question?
yes. He asked me if he was surprised that I didn't mention immutability, and he wanted to know if it was like intentional. Thank you. So, for example, I didn't mention recursion neither.
Recursion, yeah, sure.
And I think there is time to show them this, and I think I just forgot about it. Sorry. No, but that's the thing we talk a lot more. Maybe on the Scala side, maybe on the explanation on what a var is and what a var is.
Yeah. Well, especially when you use it as really important.
Yeah. So
From a pure ethnic perspective, it's not much.
maybe it's more on the how we do in Scala and when they have questions about Scala and it's just another one.
No, maybe you could, but you really have to be close to the mic.
All right. Thank you. It was unclear to me. I'm quite new to functional programming.
Yes.
So I currently develop in Java, no judgment. And so I'm not quite sure I understand what a funter is. Could you elaborate on that?
Can I say read the manual? No, I mean, so from my point of view, a functor is about transforming things without destructing the structure. So if you think in the example of an option or a list, when you map something, you can't really alter the list. You can't, list is a bad example for this one, but an option, you can't really alter things. You can just transform the value. So if you have an option of 5, for example, sum of 5, by using it as a functor with map, you wouldn't be able to really break the option value. So you can't. Yeah, it's out. It's map. Sorry.
I'd like to ask a follow-up question or a part B question of what we just heard. The question was, what is the function? So it seems to me, so I'm a professor at a school here and I teach students. You have students who are mathematically minded and you give them one definition of function. You have students who are programming minded, you give them another definition and they look nothing alike, but they're really the same thing. Do you find that's the case, that you have a mathematical approach and you have a practical
I,
approach?
in the context of software engineering, I don't think it's the case. I think it's more about, sorry, I don't remember. It's more about examples and not really examples, but more theoretical, because I don't think there is a lot of software engineers that are really mathematically inclined. So not at this level, I think. But I may be wrong. I don't know. Maybe if we get someone that has done a bit of category theory in his mathematical classes, maybe it would be easier to come from mathematics and try to explain the software engineering or the computer science concept behind it. Never had two experiences, so not there. Sorry.
Another one for me. So, usually, how much time do you think it takes to get someone who has no background at all in functional programming, but is interested in that, to be really operational in the being able to really propose new code, new implementations, new feature, without so much guidance, as you say, still learning? How much time does it take to get someone really in your own case of your own code base and your style and everything, to be operational from 0 to 100%?
So I had my mentor in the last company that told me that it takes a year to be really operational and autonomous. And if I take this as the goal to be operational in a year, so fully autonomous, etc., I think it might add a few months. But it really depends on the person, let's say. We have some devs that invest themselves a lot in the learning of FP, so read books, watch talks, and it might take less time for them. But I'd say 2 months, maybe more, to in the with the average one, maybe more. And then do 1 or 2, let's say. It's hard. It's dear. Yes?
The last question, sorry.
Okay, I will keep it short. I teach high school once a year, and so I really like your content. And I think one thing that affects the student when you speak about purity is that pure programs are usually easier to test, right? Because you can generate data and so on. Is this something you touch on during your onboarding process?
Yes, so we usually have the why question. I didn't talk about it here because it didn't fit the subject, I think, but yeah, we have the why question, and then we go through property-based testing, we go through the techniques we use on our day-to-day work to leverage the functional programming we have.